Hi, this is a C++ video lectures. Today we will study CopyConstr. To do this, we will need the following resources. Our class array that we have started to develop at previous lesson. Some C++ rules, very important to understand all nuances of this functionality, and some picture. So let's start. First of all, let's look at our class array. This is a small version of a vector class from STL, and it has the following functionality. It stores its value in dynamic memory, so it has member size, and number of elements in integer array, its capacity, and pointer to array of integers itself. Function, private function, add memory to increase volume of our memory. Constructor, destructor, function pushback to add elements to our array, and function show to show it. Let's look at functionality. First of all, constructor, destructor, and all functions have trace, line of code that outputted to console some useful information. Address of this object in memory, what functionality is called, and where is placed resource of our object. In this case, address of array of integers. At destructor, here we outputted at console two lines of trace. First line before actual deletion of memory, and second line after deletion. It will be useful in debug, where our program will need to much closer attention. Let's look at our main. Here we ask our user to enter initial size of our array, create an object of our class, add to it 4 elements for integers, show it, and after control trace, here we will look at functionality of our destructor. Let's compile and execute. Enter initial size, size 9, and look. Here we have creation of our object. This is constructor call. Our object is placed in the memory at address FF40, and resource is placed at address 5360. Here function show, which shows integers stored, and destructor call. Here this line is show us that memory will be deleted at this address, and this line of trace is executed after deletion. All memory was returned. It line is outputted after check with crt dump memory leaks, very convenient function from Microsoft C++ compiler. So let's look at creation of our object in detail. This is picture of our object creation. Here is our object itself. It has 3 members: size, capacity, and pointer to the actual array of integers. For example, it is placed at address 0x200, and our pointer stores in itself this address. This is stack of our class. Let's look at rules. Stack of the class consists from all data members that are declared in a class declaration. The size of any object equals to memory allocated for class stack. Look, this is all members of data members of our class, and this is stack of our class. Let's add to main some additional functionality. Let's create another object of our class, but this time it will be based on the previous one. We have done this functionality before, but with simple types, with integers. For example, int a equals 5 and int b based on a. Here is performed so-called shelf copy, where every bit of memory is copied exactly on this variable, exactly with every bit, every byte. Here, in this line, we will perform the same. At first, let's make some comments. We must comment these two lines. You will see why. Let's compile. A little delay. Compilation is performed. So let's start. Enter size, enter, and let's look at our output. We see constructor call and two destructors, but this is impossible because when object is created, constructor is called always. Let's look at rules. This rule. Constructor is called always when memory is allocated for an object. So, somewhere here in our main, exactly at this line, is created our new object and constructor must be called. Let's look at trace. We see that our destructor is called twice. First time for address FF20 and second time for address FF40. FF40 is address of our first object. So, before this control line, exactly here, is created another object and was called another kind of constructor. Let's look at rules. This rule. Every class has 4 default functionalities: constructor, destructor, copy constructor, and assignment operator. So we have here copy constructor. Let's look at our output. Exactly at this line, memory leaks. We have memory leaks. This is because we compiled these two lines of code. But let's look what will be done after we take off our comments. Let's compile. And let's execute. Enter size. And our program is crashed. So, let's look at first at our rules again. Rules. We have copy constructor and now we have default for copy constructor. What is performed? Default copy constructor and assignment operator perform only shell of copy. What is shell of copy? Let's look. shell copy copies only all data on the stack. Let's look at our picture. This is shell copy. This is exactly our line of code. And let's look. This is our first object and its stack. Its pointer is pointed on the memory in the heap. After shell copy, all stack of our object is copied exactly at the same places on our second object, and all members are copied, but for primitive types it is not bad. In the case of our pointer, this is another situation. We have two pointers which are pointed on the same memory, and it leads to first call of destructor which deleted this memory, and second call which tries to delete already deleted memory. Let's look at trace. Here, look, first destructor, trace before deletion, trace after deletion, second object, trace before deletion, and look, it tries to delete memory at the same address. This is impossible. And after we press F10, oh sorry, we're not in debug mode, we in execution, and after the destructor tries to delete memory, our program is crashed. So our default copy constructor is not suitable for this situation. We must write our own copy constructor to perform deep copy. Let's look what is deep copy. Rules. This rule. This copy is a process of not only copying stack of the class, but also creating its own corresponding resources and copying all data from resources linked to the object to copy from. Let's look at pictures. This is our deep copy. When we create our second object, we must allocate new memory at new address and copy all values from array of integers that belong to first object, and this is called deep copy. So let's write our own copy constructor. Here at our declaration, let's write array const array reference r. This is syntax of copy constructor for every class. Let's define it. And first of all, we must copy all values from right object. What is right object? Let's look at main. Our object R is placed to the right from our new object R2. So as parameter it will be called R. Here it is. Let's write array. And here, instead of 0, we must copy value of msize member from R msize. Capacity, exactly from R capacity. Pointer, let it be at first 0, and here we will make check if right MPR, if right MPR is not 0, we will allocate for our object new chunk of memory.